All right, so now I want to talk about, again, the parametric equations. When the two parametric equations are given, and the parameter t is involved, which represents time, and let's say you have an object that moves along a straight line at a constant speed, and dx dt equals some value, let's say a, and dy dt equals another value b, and let's consider the t equals to 1, let's say 1 hour. So in 1 unit of time the object moves a units horizontally and b units vertically. The Pythagorean theorem says that this object travels a distance a squared, square root of a squared plus b squared, right? Therefore, the speed equals distance traveled over time taken. Well, in our case, that would be square root of a squared plus b squared over 1, which is just a squared plus b squared. Okay. Now, the instantaneous speed of a moving object is defined to be v equals the square root. Now, what stands for a? We decided that it's dx dt, but squared based on this, plus what stands for b, dy dt squared. So this formula helps you to find speed, the instantaneous speed of a moving object when the two parametric equations are given. Now I want to talk about the arc length of a parametric curve. It's a very popular topic on the EP exam. Usually they give you these kind of questions on a multiple choice, calculator or non-calculator. So let me put arc length. And again, we're talking about parametric curve. Let's say we have this object moving along a curve and the plane given by the two parametric equations, x equals whatever the equation is in terms of t, and y equals another equation in terms of t. T represents time. Now, previously I said in order to find the speed, you take the square root of dx dt squared plus dy dt squared. Now we can find the distance traveled by this object along a curve between t equals a and t equals b by integrating its speed, right? There's nothing new. We know that the distance traveled can be found by the integral of vt dt. Now, if the particle or object never stops or reverses its direction as it moves along the curve, the distance it travels is the same as the length of the curve. So this suggests the following formula. Here's the formula. Arc length of curve equals, by the way, the condition is you're between the time between a and b, so usually they tell you what your time interval is, and they give you the parametric equations. obviously they're always differentiable, those two functions. And if the velocity v of t is given, then in order to find the arc length, all you have to do is integrate v of t dt, which means that you just need to take the, because v of t, we just defined that, equals to dx dt squared plus dy dt squared. So that this formula helps you to find the arc length of a curve. I want to show you a few examples, but I guess that would be part 3.